Pacific Power operates generating, transmission, and distribution facilities in 8 western states. To manage this far-flung business efficiently, they've chosen Macintosh personal computers to serve as front ends for a sophisticated executive information system.
Whether he's in electronic mail, into his calendar, into reports that are out on a TSO file somewhere, or into the general ledger system, which is on CICS, or into an IMS file in Salt Lake City. All of those things are accessible.
The executive should be able to get the information that exists in those particular places with a single button.
The real issue here is one of freedom and ease of use. The ability to get into a network and not care where you are in that network, where that data resides, that freedom is absolutely crucial.
In Apple's view, the most important connection in any network is the one between the user and the computer.
What customers expect from us is a wonderful personal computing experience. That's been the objective of the company since the inception of the Macintosh. That's certainly the guiding principle for all of the work we do within Apple Computer, especially in networking.
Apple's philosophy in networking is to provide connectivity to all the systems that our customers want access to without having to deal with the complexities of connecting those systems that they have to deal with today. To basically take the point and click philosophy, being able to point on a screen at an icon and have that be the way that you access information, whether it's local or remote. That's our vision of networking, to make it that simple.
The idea is to bring to networking the same intuitive, consistent interface that makes Macintosh itself so easy to use.
In a network environment, the value that Macintosh adds is by hiding the fact that the network exists.
You don't have to learn any weird language or commands. You just plug in what you want to get access to, click on it on a screen, and you have it. And it's the same whether you're dealing with local information or remote information. That's what networking should be, and that's what Apple is committed to providing.
We want the network to be transparent. We want it to disappear. We don't want people worrying about whether the wire happens to be a token ring wire or an Ethernet wire. We don't want people worrying about the bit flows on the wire when you establish a session.
Actually, all Macintoshes have networking built in since 1984 because we felt already at that time that it is an important thing to have.
Communication is a standard feature of every Macintosh, a sophisticated but easy-to-use networking system called AppleTalk.
AppleTalk has been part of every Macintosh that we've ever shipped. That is, out of the box, built into our systems, every Mac has the capability to network. You take 2 Macintoshes out of the box and a laser writer, you plug them together and you have a network.
Now, in order for this to be simple, we had to take away certain things that older systems demanded of the user, like configuration, a rather abstract and forbidding word even by itself. We didn't want you to have to do any configuration whatsoever. You look for something on the network by simply looking in the chooser of the Macintosh for things you want to use. They're shown to you iconically and with names. You pick the thing you want to use and simply use it.
The AppleTalk network system allows you to select the network type that best suits your needs. An AppleTalk Internet router lets you interconnect local talk, token talk, and EtherTalk networks together to build very large, geographically dispersed internets. And no matter how large and complex the network grows, accessing network services remains as easy as pointing and clicking.
I'm told by my marketing friends that the number of connections of AppleTalk today is somewhere between 1.7 million and 2 million.
And people are asking more functionality for AppleTalk because it's being used in wide facilities, wide area networks by entire corporations, by entire organizations.
With AppleTalk Phase 2, we have eliminated the limit of the number of devices you can connect to a single AppleTalk network. Well, actually, we still have a limit. It's 16 million devices. Devices connected to any AppleTalk network can pick the zone they want to belong to, independent of other devices. And we have reduced the broadcast traffic to a minimum by using several very sophisticated techniques. And we've done all of these things while maintaining complete compatibility with all existing AppleTalk applications.
With AppleTalk, Macintosh provides plug-and-play networking. It provides the Macintosh desktop extended into a networking environment. Now, we think that that's the way to do networking. And so we want to take that end-user experience and extend it beyond AppleTalk. Extend it, in our words, into 4 key environments. Digital, and we're working closely with digital, IBM, TCP/IP, and OSI.
Apple Computer and Digital Equipment Corporation are integrating Macintosh and VAX computers into a common information environment. With AppleTalk for VMS, a VAX VMS computer system can join an AppleTalk Internet, and any Macintosh computer on the Internet can access the processing and storage capability of the VAX. Macintosh personal computers can participate fully in IBM's Systems Network Architecture environment. With a variety of products that support the key data links in an SNA network. They can connect to token ring local area networks, coaxial cable, and SDLC links. With MacDFT, Macintosh computers can emulate 3270 terminals with the added value of copy and paste functionality. Macintosh personal computers can participate as peers in SNA environments, running cooperative processing applications based on APPC and communicating with other computers on the network. TCP/IP is a widely used industry standard for connecting computers from a number of manufacturers. Macintosh personal computers can be integrated in TCP/IP-based networks over Ethernet, and local talk networks can be connected through a gateway. Either way, you have access to the main network services with the familiar, easy-to-use interface of Macintosh. Now, with MacX, you can access host-based X window applications on your TCP/IP network. It gives users the look and feel of the Macintosh user interface when manipulating X window. Macintosh will also be integrated in network environments based on OSI protocols. Apple has developed an X25 gateway solution and is committed to providing other OSI services as these standards are formalized. No matter what kind of network your Macintosh connects to, you still enjoy the same intuitive, consistent, and direct methods for accessing and manipulating information. With Macintosh, you can access several different environments at the same time. You can run host applications and local applications simultaneously. And you can copy information from other environments and paste it into Macintosh applications, so you can deal with it easily, view it in your own way, and work more productively.
We need to provide tools within our system that allow developers to write great applications which can rely on the underlying plumbing.
You can use Apple's HyperCard software, for example, to create custom point-and-click interfaces which hide the complexities of mainframe applications from the end user. With Mac Workstation, you can enhance mainframe applications so they can make use of Macintosh interface features, making those applications easier to use and preserving your investment in software and data. Using CL1, you can build cooperative processing systems with host database managers and Macintosh applications working together to provide transparent access from local Macintosh applications to host data residing on a digital VAX or IBM mainframe.
The promise of networking is to give users electronic access to information or people around the world, very simply by making the network transparent.
You can share information between users. You can communicate user to user. You can open up basically the world to people. You can give them the freedom to make their choices of what systems they want to use and how they want to connect them together. And all through the same consistent interface, the Macintosh.
What we're trying to do is to make the information that is in some sense locked up inside the steel walls of the mainframe, liberate it, get it onto the desktop so our customers can use it to be creative and to do something productive for their organizations. We think that the application of the Macintosh look and feel to mainframe applications, to mainframe information, and to complex computer networks, done correctly, that's what we bring to the table. As Apple's Vice President of Networking and Communications, I direct all of our company's data communications research and development. It's a very exciting assignment because Apple has made major commitments in the area of networking and communications. The company has acquired 2 outstanding firms in that field. We've announced and shipped a number of new products, and there's a great deal more to come. And all of it builds on the idea that got Apple started in the first place, helping people to extend their abilities by creating computers they can use to do extraordinary things. It used to be that mainframes and personal computers lived in 2 separate worlds, the mainframes doing the big jobs and the personal computers helping individuals to be more productive. Each had its place in the scheme of things, and each offered advantages, but neither could tap the strengths of the other, not easily at least. When you bring these 2 worlds together, not only do you increase the capabilities of the individual, but you also make the existing mainframe system more useful to the organization. And when that personal computer is the Macintosh, you provide your people with a tool they will enjoy. The Macintosh has an intuitive interface that people learn quickly so they can get on with their jobs without the need for a lot of training or continuing day-to-day support from the information services people. We'd like to show you how the Macintosh can serve as a terminal for IBM, DEC, and other hosts, and how the Macintosh interface enhances terminal emulation. How you can transfer files to and from the host environment, work with the host application using the familiar features of the Macintosh interface, and finally we'll show you how the Macintosh can be a true software peer in a multi-vendor environment, conversing and working with applications on the host. You'll see how it's done, and you'll see too what practical benefits arise when Macintosh and mainframe get together. The entire information system becomes more valuable because people can do more with it. The source of these benefits is the architecture of the Macintosh. In conventional personal computers, applications sit directly on top of the operating system, which leaves developers on their own to define a human interface. That's why different applications end up looking and behaving differently. But the Macintosh architecture was conceived and designed to provide the support for a human interface that remains consistent across different applications. That consistency is assured by the toolbox, which includes a set of routines that applications can call upon to display interface features, such as windows, menus, and icons. The Macintosh architecture also includes a layer called a desktop that gives users an easy way to manage disks and files, launch applications,
carry text and graphics from one document or application to another, and access network resources and services. The toolbox and the desktop bring consistency and a graphics-based, intuitive interface to the Macintosh, enabling users to learn a variety of applications easily and to integrate them by cutting information from one application and pasting it into another. Now, this consistency is a great advantage for the user of a standalone personal computer, but where it really pays off is in the multi-vendor environments. For just as Macintosh makes it easy to move information between applications, it also makes it easy to move information between environments and allows you to give users one easy, consistent, and intuitive way to make use of all of your information resources.
All these features give Macintosh a natural fit with large information systems, where people work with data that's distributed in more than one place and more than one environment, and where people use a variety of applications to analyze and present their findings. Macintosh can emulate the terminals you use now, so that information can flow easily between the mainframe and the desktop, without any need to modify the programming on the host. Once people have the data they need, Macintosh lets them do a lot more with it than they could using a dumb terminal. Now here's a 3179 terminal. We're connected to an IBM 3090 running TSO. And here's how easy it is to use a Macintosh to do the same job. I'll unplug the coax from this terminal and plug the same cable into this Macintosh. On the Macintosh, we have our 3270 emulator. I follow the same procedures to make the connection and to access the host, and I enter the same user ID and the same password. And what we see on the Macintosh is the same information presented in the same form as it was on the terminal, and I can work with it in exactly the same way. We can connect and communicate without any changes in system administration. As far as the mainframe is concerned, the Macintosh looks and acts just like an IBM terminal.
But when the Macintosh is acting as a terminal, you'd expect it to do a whole lot more, and it does, because we can take advantage of the Macintosh to do more than just view the data. So, while we're connected, we'll access a report generated by the host database program. I select the data we want to view and copy it into the Macintosh clipboard by selecting Copy from the Edit menu. Now, I can open a Microsoft Excel spreadsheet, or any spreadsheet for that matter, running under the Macintosh operating system. I select Paste to put the data into my spreadsheet, and I can manipulate it just as though I've typed it in all by myself. Now, to make the data part of a report, I'll create a graph, paste it into a document, and print it out.
What we did in the IBM environment, we can do just as easily in other environments, such as DEC, for example. Let's connect to a VAX, and let's do it while we're still in session with the IBM system. We can use any of a number of VT100 terminal emulators.
So we'll get the data we need from a VAX database report, and there it is. I'll select it, copy it, and paste it in the spreadsheet. And so, a user can take data from a host and, through terminal emulation, get that information into the Macintosh environment, where it can be treated like information created on the Macintosh. Word processors, spreadsheets, and whatever else I want to use are right at hand, waiting to receive information from any number of hosts. In fact, from this spreadsheet, I can actually open a report that resides on the VAX and import the data directly into the spreadsheet.
Digital Equipment Corporation and Apple have been working together to provide even closer Macintosh to VAX integration.
So when the Macintosh is connected to a VAX system, it is fully integrated into your network and can make use of all the network's functions: electronic mail, file access, remote terminal services, and interprocess communications. So, as you've seen, you can use Macintosh for terminal emulation in your existing information system, the mainframe computers, the communications hardware, the cables. The value of doing that with a Macintosh instead of a terminal is that you can transfer information to the Macintosh and manipulate it there, with all the benefits of the Macintosh interface. File transfer can mean less use of host CPU time and less network traffic. Because host files can be accessed and transferred to and from the Macintosh with point-and-click ease, Macintosh users can work with the data in their own way with local applications and with minimal support. And when they're done, send their work back to the host, making their reports and data accessible to others on the network using the mainframe as a large file server. Many of the people who need to use information aren't experienced at using computers. So the next level of Macintosh to mainframe communications makes host applications look like Macintosh applications to end users. Here, the Macintosh interface provides a front end to mainframe software. Dealing with complicated host applications, either through a terminal or through a conventional personal computer, can be difficult. And that can mean data sessions that are longer and more complex than they really need to be, and inefficient use of your information resources and your people's time. The Macintosh interface can help you get more out of your investment in existing host systems because it can make those systems easier to use. Here, we're using Apple's HyperCard software to work with a mainframe SQL database. HyperCard gives you the programming tools to build front ends for mainframe databases, to use Macintosh interface features such as windows, icons, programmable buttons, and graphics. So the user can connect to the host, request information, and update data with the same intuitive point-and-click interface of a local Macintosh application. It communicates with the host through an SQL-based connectivity language like CL1 that translates the user's inputs into the host's own query language. Absolutely no changes are required to the host applications that also access the database. And when the data is transferred to the Macintosh, CL1 makes the information available in a form that HyperCard can use. The background form that the user sees is part of the local HyperCard application. The data that fills in the blanks comes from the mainframe. There is a growing number of Macintosh applications that can use CL1 to communicate with existing SQL databases. Besides HyperCard, there are databases and spreadsheets available that can work with these host applications without any modification to the host software. A tool called Mac Workstation makes it possible for a programmer to add a Macintosh interface to a host application without having to learn Macintosh programming. The host application can be written in any language, so programmers can use the skills they've already developed and even applications they've already written. Mac Workstation runs on the Macintosh and acts as a bridge and a translator between the host application and the Macintosh toolbox, bringing the Macintosh interface to mainframe data. To use Mac Workstation, the host programmer adds commands to enhance the existing application, so the application can specify what the Macintosh will display to the user. This code tells Mac Workstation to display a dialog box. This identifier can be followed by a character string to add more details, such as text. And other commands invoke other elements of the Macintosh interface. When the application runs, it will send these messages to the Macintosh. The amount of data added to the transaction is very small. It doesn't include all the graphic details, just the specifications. So network traffic is less than it would be if the host had to spell everything out. Mac Workstation is an extension of the Macintosh toolbox that interprets the message and calls other features of the toolbox to draw a dialog box. And what the Macintosh user sees looks like a Macintosh application. Clicking on the button will tell Mac Workstation to return a response to the host. And what the host sees is the command code it expects. Here's a database session as it runs from a VAX terminal. And here's the same application driven with a Mac Workstation front end. To add this kind of enhancement to host applications, programmers don't have to learn Macintosh techniques. Mac Workstation allows them to invoke the Macintosh interface with a minimum of commands to give their clients the power of mainframe applications with an interface that makes those applications easy to use. Differences between data formats, query languages, command languages, and file management conventions need not stand in the way of adding the strengths of the Macintosh to those of the mainframe. Here's another example of Apple's commitment to connectivity in multi-vendor environments. Mac APPC, Apple's implementation of IBM's LU 6.2 protocol. It enables host applications and Macintosh applications to work together, even though they are written in different languages. With Mac APPC, Apple became the first vendor to successfully complete the IBM LU 6.2 interoperability test. With Mac APPC, applications running on the Macintosh can converse with those running on host systems as true software peers. They can access distributed databases transparently wherever they are located, and combine that data with information maintained on the Macintosh. Cooperative processing takes advantage of the best capabilities of Macintosh personal computers and host systems. The Macintosh personal computer does more than merely connect seamlessly with other devices on a network. IBM, digital, mainframes or minis, terminals or MS-DOS personal computers. The Macintosh adds significant value to enterprise-wide information resources. It can make accurate, timely information readily available to those who need it in a way that's remarkably easy to use. And that, after all, is the bottom line, helping people to be more creative and more productive.
The tools we've shown you are designed to help you integrate the Macintosh into your information system. And you don't have to scrap your present hardware to get the benefits of Macintosh technology, to provide a higher level of information services to your whole organization. We consider Macintosh a valuable addition to any information system. It enhances your investments in both hardware and data because, as you've seen, the Macintosh and the system you're now using can work hand in hand, each doing what it does best, and together helping your people to be more effective, more creative, and more valuable.